Welcome everyone. Welcome to this edition of the GitHub webinar. And today's topic is we're going to talk about securing your code with securing code and production with GitHub. We'll take a deep dive into how GitHub Enterprise can help you build faster, better, and more securely. We'll show you how to build security into your GitHub workflow, keeping secrets and vulnerabilities out of your code base from day one. And by the end of this session, you'll be able to you will know how to stay on top of vulnerabilities as they arise and be able to leverage the security community's expertise without compromising your code, right? So this is like very focused on making your entire setup more secure. And a little bit about speaker today. Today's speaker is Dhanashree Chauhan. Dhanashree Chauhan is a senior enterprise advocate at GitHub, and she works closely with the developer community to build awareness around GitHub products and features. She advocates for customer needs internally, and prior to GitHub, she has spent over 14 years in US and Malaysia in roles spanning engineering, professional services, and sales. Cool. And before I hand it over to Dhanashree, I would have a few housekeeping announcements. So first, you can ask any questions you have in the chat, and we'll answer them over the course of the webinar. And yes, I think many of the questions you have, especially on the demo, should be answered, I guess, in the demo. So we have a recorded demo which Dhanashree will be playing. And yeah, we'll be answering the questions in the chat as well. One last thing I want to say is, like, all of you are part of the Microsoft for Startups program, and as part of Microsoft for Startups, you do get access to GitHub benefits. So if you haven't redeemed GitHub benefits as of now, my suggestion is to log into Founders Hub and actually redeem those benefits and start using them, because there are lots of good things, a lot of goodies in there, whether it is GitHub Actions, whether it is like issues and normal developer workflow. And also, I think today we'll be talking about security, right? And towards the end of the webinar, I'll be actually posting a feedback form. So would love to get your feedback so that we can plan many more seminars on this. And last but not the least, this is getting recorded, and I'll post the details of where you can find the recording in a week or so. So you can check it out, the slides and all of the content as well. So with that, over to you, Dhanashree. So let's get started.
Hey, thanks a lot, Vinayak. Hey, everyone, and welcome to this session on securing your software lifecycle with GitHub. I know folks are joining in continuously, so just to give a quick recap on what Vinayak was saying, today we will do a deep dive on how GitHub Enterprise plus GitHub Advanced Security can be leveraged to build security into your GitHub workflow. We'll see how to keep secrets and vulnerabilities out of your code base from day one, okay? So as Vinayak mentioned, you guys are, all of you are part of Microsoft for Startups. Please take good benefit of that. Leverage the GitHub Enterprise credits and licenses that you have, and we are here to help you and support you in any way. So just an agenda item. My presentation and demo is roughly 50 minutes. I don't know, even if we don't have time for Q&A in the end, please keep this as interactive as possible. Please enter any questions you have in the Teams chat window. We'll certainly get to it. And if not during the session, we can send you an email or, make sure that your questions are answered. If you have any questions on how to leverage, any of the things that you're seeing today, or if you have any questions around pricing and stuff like that, or even any technical questions related to what I'm going to present today, please feel free to email us at startups@github.com. Okay, like when I mentioned, you will be getting a recording of this session afterwards, so please stay tuned. So for those of us joining right now, hi, I'm Dhanashree. I'm a senior enterprise advocate at GitHub. I joined about a year and a half ago, GitHub, and it's been an incredible ride. I think I'll talk through some of the numbers and just the progress that I have seen while I have been here to give you a context of how quickly this rocket ship is going. Okay. Now, a quick level set on who we are. I'm sure since most of you have joined, you've at least heard of the name GitHub. So a quick background on how we even got started. Back in 2007, 2008, three engineers really wanted to come together and create a social platform for developers to host and share their code. So our co-founders took Git, which, as you all know, is a distributed source control management system and built on top of this. What they wanted to really do is make a more internet friendly, more browser friendly platform for developers. So cut to today and all of those, 10, 11 years, especially over the last 3.5 years, we've evolved from just being a source code management system all the way to a complete developer platform. Today, you all know GitHub as the home of open source. Some of the largest open source libraries and projects were born on GitHub. They continue to thrive on GitHub and attract this amazing open source community. But along with that, we have 94 million developers coming to us from education, so high school students, from startups such as yourselves, from government agencies, from large enterprises. In fact, 90% of the Fortune 100s are using GitHub today. And our hope and wish for all of you as startups is you reach this unicorn status and beyond very, very soon, and you continue to leverage GitHub as your platform of choice. I think one of the biggest questions, most frequently asked questions and biggest top of mind thing for folks is how are we different from a tool like, say, GitLab or Bitbucket? And I think the most important, unique differentiator is we allow you to choose the programming language of your choice, the CI/CD tool of your choice, the framework of your choice. So you can continue using what we have, and we are the largest DevSecOps system and platform on the planet today. You can plug in all the tools that you're using and continue, seamlessly integrating with GitHub and leveraging all the best features that we have to offer. I think another thing for me is just the fast pace at which we are growing is also why most innovative companies today, like Stripe, Spotify, Slack, Shopify, are using us. So just to give you a context, when I joined a year and a half ago, we were at 54 million developers on the platform. Today, we are at 94 million and growing rapidly. And this is not right. It doesn't translate just into numbers. What happens is then we can get the collective wisdom of all the folks from open source, from enterprises who are using us, talk to all the clients, look at what the pain points are, and then integrate that wisdom back into the platform. And I think that for me is really, really exciting. Okay, so the topic for today, application security. So before we drill into the details, it's very important to really step back and even understand why application security is so important. So we've seen, protections around networks, making sure phishing attacks don't happen, but turns out that flaws in code are also dangerous. So in fact, flaws in applications are consistently the number one attack vector for breaches, and 85% of applications today still contain known vulnerabilities. And this is very scary, right? Because we are pouring billions of dollars of investment into security scanning tools, and applications are still remaining insecure. And this fact really blows my mind. A line of code which was written in 2016 is as likely to introduce a security issue as code that is written today in 2022. So as you know, GitHub, like I said, is the home of open source. But what we've done is, spoken to all of these clients to try and understand why is this state of AppSec, what is really causing it? And we find that there are three major buckets or pain points that we can figure out. So one and first and foremost is developers and security teams have remained siloed, and I'll talk about why that is so. Another important thing is that there is a huge skill gap today in the industry, and there's a really skewed ratio of security to development professionals. So today we are seeing that that ratio is almost 1 is to 100. And you can imagine that basically means that we are churning out a lot of code, but they may not be necessarily, the amount of security researchers or people with security expertise to then audit or remediate those security vulnerabilities. The second thing we are seeing is all of us today, you hear this transition to cloud native environments. Of course, you being startups are already on the cutting edge of technology, but customers are shipping code more frequently than ever. So security teams are really struggling to keep up with the space of development. And this results in lots of security technical debt. And I'll talk towards, when I speak about the demo, you'll see how we are trying to tackle the security debt. The third thing we are seeing is due to the vastness of modern code bases, many organizations today rely on multiple fragmented tools. Now, what happens is a developer is not expected to know just the part of the software development lifecycle that they are handling, but also other tools, other programming languages, for instance, which is challenging. This means that remediation in a typical organization can be anywhere from 3 to 6 months, and you can imagine the hackers are not waiting around for 3 to 6 months. They are, poised to attack at any small vulnerability, any small gap that they see. And this is why the state of AppSec and application security is important to handle. Now, let's take a look at this graph. At GitHub, what we did was we analyzed around 70 million lines of major open source software projects. So if you look at this graph, you'll see as the number of lines of code increases, the commits mentioning vulnerabilities increase as well, which is the purple line that you can see. And this kind of makes sense, right? More code, more vulnerabilities. What is scary is this red line that you see. That means that security threats are increasing in a linear pace with the other two lines. What does this mean? It just means that even though developers are aware of the risk of vulnerabilities, we still don't see a reduction in threats. Now, this is just a very brief snapshot of some of the breaches across some of the major names and across all industries, whether it's software, whether it's food, whether it's travel. All of these are, or telecommunications, all of these industries are being impacted with the attack vector, like you can see, is really large for people to take advantage of. And this is what we are trying to avoid. Now, I was talking about the silos, right? What really causes these silos? So let's just take a look at that. So typically what we've seen is this is what the developers focus on. They want to code new features. They want to deliver features on time and budget. Now the security teams may want to make sure that you update your dependencies, you keep your code secure. And then comes the ops team where they want to make sure everything is running reliably, right? So what it means that the business challenge today is we found that 68% of companies say that their CEO demand that DevOps and security teams do not do anything that slow the business down. In fact, 44% of developers today are not even trained to code securely. And this is a huge silo, and this is, although not an ideal scenario, this is what the reality today is. So what most organizations thought was that we will shift security left. I'm sure most of you have heard the term, but essentially what that means is instead of identifying vulnerabilities at the end of your software development lifecycle, we identify those in the beginning itself while the developers are writing code. In fact, I can go as far as to say that you can shift this even further left in the planning phase. If you have someone on the security team who can review your architecture, who can make sure security best practices are advised and recommended even at that stage. But as you can see, the remediation cost for a breach or a vulnerability that is found in production, or God forbid, if a breach happens, is so much more higher than if you had to remediate that in your development phase itself. And this is exactly what we mean by shifting security left. So when GitHub decided to move into application security, we didn't want to be just another scanning tool in the market. Okay, it was very important for us that we actually empower developers to fix what they find, which means provide high quality results, fewer false positives, lesser jargon, and more actionable feedback back to the developers. So how do we do this? We do this by natively embedding that security finding inside the developer workflow. And let's see how we are doing this one by one. Okay. So native application security. And for each of these buckets, I have mentioned some customer testimonials because I honestly believe that more than a product, it's the customers who talk about how they are using the features and how it benefits them And that is so important. So, like Lee at Dow Jones is telling us here, security is really, really critical. So, what we want to do is our mission is about supporting our customers to deploy their products quickly and safely. And this means making security a native part of your process. And by process, I mean from init all the way to ship. So GitHub Advanced Security can be deployed across every repository in your organization. And once you enable it, security testing and remediation happens in the same workflow that you use to build your code. You will see all of this in the demo. I walk through all of this one by one. So, just I think it's very, very important to set the base of what you're going to see next. Another thing we do is, like code changes, we do provide detailed change logs. So this is demystifying the progress, simplifying audit and collaboration. You must have heard this term inner sourcing, right? So inner sourcing is essentially taking the best practices that we see in open source projects, in open source libraries that help them to scale and deliver software securely. We try to bring in those best practices within the perimeters, within the boundaries of your startup, your organization. And that is extremely important. And the way we do it is by providing these features, by providing, say, dashboards that allow you to triage this risk and have complete visibility across your organization on your risk posture. Another thing we do is trust by design. What this means is at the pull request itself, we are testing for CWEs or the security bugs in the code. And we are looking for potentially leak secrets or vulnerable dependencies. So this is a proactive approach. So we are stopping bugs or vulnerabilities from ever making it into your main branch ever. Now, another thing that I really like is suppose you wanted to pull in an open source or commercial container security scan, you can easily do that in a seamless action workflow. Again, something that I'll run through in the demo. But what's important is that all these results are provided to you in a single pane of glass. So they are right alongside your native GitHub testing results. So you don't have to context switch. Speaking of context switch, I don't know if you have heard, but we have found, and most studies have found that if developers had to switch context, it takes them anywhere from 20 to 23 minutes to get back into flow state. Flow state is where they are the happiest and most productive, and they can code securely and reliably. So that is very, very important. So you can understand why I'm talking about context switch. So instead of going to a tool, a separate tab, which where the security results, for instance, are displayed, that is going to cause this context switch, right? A lot of friction. And that is the friction that we are trying to avoid and make developers really, really happy. The third thing we say is fix in minutes. So for every finding that we are finding, you will be empowered with clear visibility into the origination of the bug or the secret or the vulnerabilities. In fact, for findings that GitHub can automatically fix, we will actually create a pull request and give you compatibility scoring to let you know if any code changes could cause functionality issues. For other fixes, like I said, you will get detailed jargon-free remediation guidance. Again, talking again and again about jargon-free remediation, this is very important when you're talking in real life scenarios about developers who are just trying to ship that feature to market, really, really quickly. When you give them something that they understand and they can actually take action on, it's extremely powerful and important to them. The best part is GitHub is all about community. We love our community, especially folks like yourselves who are joining us from all over the world. And what we do at GitHub is we believe free and open security data is critical to empowering the industry to best secure our code together. So it's not the responsibility of any one individual or any one organization. We need to come together to fend off all these attacks. So we are in fact the second largest CNA to the National Vulnerability Database. And as a GitHub user, you benefit from GitHub working with maintainers to disclose open source vulnerabilities. In fact, today we have 60 plus token providing partners to make token patterns more identifiable, increasing the accuracy of leak secret detection. And the best is it's scaled by leading researchers and organizations around the globe, like Microsoft, Google, Uber, and others. Now, talking about these four buckets, I want to talk to about three main things that we will also be covering in the demo. But what Dependabot is once you have your environment set up in your GitHub repo, it's important to ensure that all the code you are developing is secure from end to end, right? This includes your dependencies, and this is where Dependabot comes in. So when we are notified through various channels, National Vulnerability Database being one, or GitHub Advisories being another, Dependabot gets to work. So it'll send you a pull request to update your dependency. It also allows you to shift security left because you are provided with the predictive information to catch vulnerable dependencies before they even hit production. In fact, and these numbers are so important, we have seen that for repos or repositories that have Dependabot security updates enabled, the mean time to repair or remediate is just 40 days. And compare that to the industry average of 6 months, right? So that's really powerful. Now, in addition to securing your dependencies and software supply chain, it's important to ensure that the new code that you're developing is secure and compliant. And that's where code scanning comes in. GitHub code scanning is powered by technology called CodeQL or Code Query Language. And it is a revolutionary semantic engine which was developed based on almost 13 years of research by a team at Oxford University. So this is a language we use in order to find vulnerabilities. And we are not looking just at the regex type patterns, but we are actually able to find the logic of your code from source to sink. Just to give you a quick example, think about a SQL injection attack, right? So for instance, if you're pulling in information from an untrusted source, say like a REST API, it's flowing through many different methods and many different files, finally to an unsafe sink, maybe if you're executing a database query, but you're not sanitizing anything in between. And that just forms the basis of your SQL injection. And that's where CodeQL comes in. Again, you will see this beautiful UI where I will walk through the source to sink path flow so you can see that in more detail. Now we have something called GitHub secret scanning. What we are doing is looking for fraudulent use of secrets that were committed accidentally. And we are looking and finding secrets the moment they're pushed to GitHub. So the developers are immediately notified once these are found. So we have expanded our coverage to include private repositories for secret scanning. And this is really now today is available in two forms on github.com. So one is secret scanning for partner patterns, and I'll talk about some of the partners that we have. The second is the secret scanning for GitHub Advanced Security. So these are just some of the secret scanning partners. We continue to add more and more partners. So essentially, anytime we find, if a potential secret is detected, what we do is we notify the service provider who issued any secret, and the service provider validates the string. Then they decide if they should revoke the secret or issue a new secret or contact you directly. It really depends on the risk posture that you have. Okay, so another customer testimonial, LinkedIn, all of us are aware of this. They saw almost a 40% increase in their developer-related NPS scores. They have 2,900 developers onboarded and seamlessly using and building upon custom infrastructure. They use GitHub Advanced Security to surface vulnerabilities early, to improve their code quality and reduce their risk. So with that, let's move on to the demo. For today's demo, I have tweaked things slightly. Just last night, around the same time, I recorded a demo, so I could actually look at the chat questions if you have any and answer them. Okay, so let me just
Uh,
move over real quickly. Yeah.
yeah, so Dhanesh, there are a couple of questions in the chat quickly before we move on to the demo. The first question is by Marco. He asks, do you have any reference for the context switch thing? And he
Sure.
would love to dig deeper.
Okay. Sure, Marco. I will definitely look at these questions once I start the demo here.
Sure. And I think Vincent's ask, is Git Guardian a part of GitHub?
No, Git Guardian is not a part of GitHub. Again, we'll send you links. Thank you, folks. Vinayak, you can see my screen with the demo.
Yes, I can.
Okay.
Can you start playing it and yeah.
And welcome to this demo for GitHub Advanced
I
Security
can hear the sound as
on
well.
securing your workflow with GitHub. So here I am on one of the repositories that I have defined, Bookstore Startup 16, which resides within an organization called Octodemo. And I really want to look at this from the perspective of a developer. Now, for this demo, this repository, sorry, basically this is just a demo bookstore application. And what this is just a simple Maven project. It builds a standalone jar. It contains a Jetty web server and some other servlets. Now, one of the things we can see here is GitHub is smart enough to actually surface some insights about the kinds of programming languages being used within this repository. And most projects today typically contain a mix of programming languages, and this repo is a good representation of that. Okay. Another thing to mention here is, as you can see, this readme.md is something that you should have for your own projects as well, which explains for any person joining the project, or who's not really familiar with what the background is, to quickly get up to speed about what this project does. Okay. Now, one thing we all know is in today's modern software projects, 80 to 90% of code is typically coming from open source dependencies, right? Remaining 10 to 20% is just the custom code that you would write, which is really your business or your startup's USP, what you are going to market with, right? So it's very important that we are able to secure those open source dependencies. Now, what GitHub has done is we've now given you a very simple way of figuring out these open source dependencies. So what I could do here is under my repo, I can just go over to the Insights tab. And if I scroll down here to this section, and on the left-hand side, you'll see this option for dependency graph. Now, if I click that, you will see that what GitHub does is gives you a summary of the manifest and the log files that are stored in this repository. And it further breaks down these over here in the section here, and you can see all the direct, but also the indirect or the transitive dependencies over here. So essentially, you're getting a descriptive analytics of your security vulnerabilities, and this is very powerful, right? For instance, I can just click this, and you can see one cool feature here is GitHub is telling you what is the version of this, where we think that this particular dependency will not have a vulnerability. So it's also giving you these recommendations. It's giving you all these links right here within this single pane of glass to go and look at the CVEs, which you can find, which we will talk about a little more. Okay. Now, another thing you can see here is Dependabot. Dependabot is another powerful feature we have. So if I actually went ahead to the security tab, there are three things you can see here: Dependabot, code scanning, and secret scanning. So let's talk about Dependabot. What Dependabot does is it's checking for your outdated dependencies as soon as that feature is enabled. So the way it works is GitHub watches the National Vulnerability Database and other sources for vulnerabilities in open source packages. So if Dependabot finds a vulnerability in a package, alerts would be generated. Now you'll see there's this nice grid view that you can see, and you can filter these results by package. So I can look into which packages I have, which can also actually help me prioritize my remediation. For instance, if I had a package here which had say 40 results, right? That is something to look at first. I can also go ahead and look at my ecosystems. Over here, I have NPM and Maven. I can also look at the manifest files, right? And sort by that. There are other things I can sort by, which is the severity. So basically, I can prioritize my remediation here. Now, let's go ahead and look at one of these alerts that I can see here. This one is for a command injection. You'll see that GitHub is giving you this where we can see this vulnerability, but it's also giving you all these information or all these statistics and information here, which is these are industry standards, right? So it'll show you the common weakness enumeration and a link to that saying what is the description, what is extended description, why is this being surfaced even, right? So yeah, in addition to the CVEs, we can also see the CWEs, which is the common weakness enumerations, and the CVEs, which are the common vulnerabilities and exposures. So again, as developers, we are not really security researchers, but having something like this at the click of a button is very powerful again for developers. So they can be empowered to fix a particular vulnerability. Another thing that you'll see here is this button for creating dependabot security updates. Now, what dependabot security update does is it can fix the vulnerable dependencies for you by raising pull requests with the security updates. So what dependabot checks is whether it's possible to upgrade the vulnerable dependency to a fixed version without disrupting the dependency graph for the repository. If I go ahead to the pull request, I had one of these that I had already created. And what you will see is that Dependabot is showing you there are two types of alerts that Dependabot would actually pull in the pull request. One is the security updates, which are the automated pull requests that would help you update dependencies with known vulnerabilities. But there are also these updates with even if there aren't any known vulnerabilities, what Dependabot does is it helps you keep up to date with the latest versions being used within your files, right? So over here, of course, this was raised because of alert, but there are other things that Dependabot would do, which would give you, which would help you instead of a developer going ahead and actually making these changes manually. This is something that Dependabot has opened for us. And what we can see is once these checks have passed for us, the ones that get triggered anytime I open a pull request, once those pass, what I can do is then I can just go ahead and merge this pull request, or I can approve the review or tag someone to look at this further, right? So what we are doing is basically saving a lot of man hours. Now, I say this because we know of customers who have a team that is dedicated to keeping a track of these open source dependencies. So while you can configure the system, of course, to make these merges at automatic, um, we are actually making sure that merging is blocked because of the policy that we've defined, here, because we need one approval review, again, another part of security, if you will. But basically, the owners of this repo have full control over what can merge back into their main branch. Now, an interesting point to note is that Dependabot is available out of the box for GitHub Enterprise users. Now, if you want to prevent the dependency from even reaching the main branch in the first place, GitHub Advanced Security actually provides you with this feature, which is called dependency review. Okay, so if I scroll down to these checks that were triggered when we opened this pull request, I'll see something here called a dependency review or a dependency pull request. Now, if I click on the details here, basically what's happened is a GitHub action is being called here, which is called the dependency review action. Now, what does this action do? It is basically going to scan for vulnerable versions of dependencies introduced by package version changes in your pull request, and it's going to warn you about those security vulnerabilities. So it gives you a better visibility of what's changing and helps you prevent vulnerabilities from even being added to your repositories. So over here, of course, I don't have an error, but I wanted to show you really quickly what something like that would look at. right, look like? So as you can see, not only are we looking at things that have already been introduced, but we are proactively trying to prevent any errors being introduced in the first place. Okay. Now that sort of covers the open source dependencies. Now, how about the code that we are writing, right? So if I look at again at my organization and my repository that I have, and all of this code that I have within here, another thing that GitHub Advanced Security gives you is something called code scanning. Okay, so CodeQL or code query language is our semantic code analysis engine. Now, what we are trying to do is really automate security checks. Okay, now it's setting this up for the first time is very simple. It's as simple as adding a scanning tool here. As you can see, CodeQL is already configured, but all I had to do is if I click on configure here, what happens is you'll see I went from the security tab into my code tab. And within the .github workflows folder, I have a YAML file which is being defined, which is this CodeQL YAML. Okay. And basically, this is where, I am configuring my CodeQL scan. Now this is, GitHub Actions is a separate session altogether. If you wanted any further information on how to configure GitHub Actions, please drop us a note and we'll be happy to point you to either pre-recorded sessions or upcoming sessions for this. Okay, but essentially the point is that it's extremely easy to customize and extremely easy to get started. All I had to do now is start commit here, and that's it. Code scanning would be configured for my repository. Okay. Now, since we already have this repository and this code scanning enabled for this repository, I'm going to go ahead and look at these results. Again, like Dependabot, a grid-like view, very simple. Now, what you can see here is, and this is something that most of our clients find very, very useful, is you can sort all of these results by the tools, right? So if you have multiple tools here, for instance, you've added one for infrastructure as code scanning or another dash tool, for instance, the results will all show up within, again, a single pane of glass. You can also look at the branch that you want these results filtered by. So for instance, if you had a test branch, you're not really concerned about fixing those vulnerabilities immediately. But if there's something within your main branch, which is of critical severity, that is definitely something you want to look at immediately. One point I do want to call out here is CodeQL is different than other SaaS tools in the market, right? And that is because, unlike other tools that rely only on regex matching, CodeQL actually lets you query code as though it were data. So for instance, other tools that use pattern matching can throw up a lot of false positives, like say you have this error which is in a comment, or you've written this really funky method, but it's not being called anywhere. What happens is that the developer is now getting a number of false positives. And that is what we aim to reduce at GitHub with the CodeQL. And we're trying to reduce that noise to signal ratio, and this is very, very helpful to the developers in reducing the number of man-hours when we are tracking these false positives. Okay. So when you're comparing it with tools like Sonar Cloud or Checkmark, this is definitely, it stands out for the better. Now, Log4j is something we are all very, very familiar with. Now, let's look at one of these vulnerabilities in details. Okay. So when I look at one of these vulnerabilities, I can click on this show more and I get a link to the CVE that is that is actually causing this alert. Okay. Um, it's telling you the path. It's telling you what kind of severity this is. It's telling you the version. And if there is a fixed version available, it will also show this to you. Another important part is that these code scanning results can actually also be integrated right within your pull request. So if I had to go here, for instance, as I mentioned earlier, this is a bookstore, right? If I looked at issues, there is this issue here to add a search feature to my bookstore, right? So I have a teammate who already made these code changes and they opened a pull request for me, which is this book search feature added. So as a reviewer, if I had to come in and look at this pull request, one thing right off the bat is that all of these checks that were automatically kicked off, right, with GitHub Actions. But importantly, I can say here that CodeQL is failing. So I can go ahead and click on more details. So as a reviewer, even before I'm looking at the files changed, I know that there are already some errors. Now, one of the most important things you can do as a startup is to make sure that you are enabling your developers to work in a quick but secure way. And because developers are familiar with the experience of pull requests, opening something like this, like a code scanning result, right within the pull request is a familiar experience. And it cuts down the time to learning and that's the time, and helps them be productive faster. So coming back to this CodeQL result that I have, if I clicked on show more details here, you can see, first of all, I can see that there's this badge indicating that this finding is from a pull request. It's showing me the name of the merge and it shows a branch that GitHub generated for the PR in which this vulnerability exists. You can see that there's a lot of contextual information to the actual alert. Okay, so we are not only providing you recommendations here, as you can see, but if I click on more, so it gives you a summary, a quick summary of what the error is. It gives you a recommendation, but it goes ahead and gives you the good and bad examples along with, if I scroll down further, you can see all of these references. So most of the pull requests that you have will have, which are opened with code QL, code scanning, will have most of this information. Now, why is this important and why am I belaboring the fact? It's because all developers are again not familiar with security findings, right? So you can imagine that when a software developer is given all of these recommendations, all of these helpful links, the weaknesses, that they can look at the external links and all of this contextual information, now that a graph which we saw earlier where as the number of lines of code increases, your vulnerabilities are increasing. Now, that does not remain just a mere statistic because at this point, the developer can actually go ahead and make a change to fix this error, right? So, this is extremely important and powerful when we talk about shifting a security left or empowering developers. Now, what I can do here is I can either create an issue for this so that we add this to say a project management board and essentially we park it for a future to do. Or another thing I can also do is dismiss this alert saying I don't want to fix it right now. Either this is not relevant to me or this is a false positive or this is not used in production code, and GitHub will provide an audit trail for you of why this was dismissed. Okay, now if I go back to this alert here, um, back into the pull request that we were looking at into the book search feature, right? So if I click on the details and as I was telling you, this is where again this is a part of the GitHub Actions and this is the workflow file which I showed you. You'll see all of these steps which are being performed, especially as it relates to code QL analysis. Okay, and all the diagnostics and summaries. If you have any errors here, this is the place to look at. And you have a rich set of logs that you can traverse through. You can even search these logs for any possible error. Okay, now, but I am digressing, sorry. So let me go back to the error that we were looking at. Now, one other thing I can do here, apart from creating issue and dismissing alert, is click on this show paths. Okay, now what show paths does is that it's going to show you all the code paths that actually led to the vulnerability. So for instance, over here, I have two files within this which are leading to this. Okay, so you can see the source where this is getting defined, and you can track it all the way down right to the sync portion. Now, in this case, both the paths, both paths, we have two paths, both of the servlets are leading to the same sync. But you can imagine how easily we can fix it here when compared to, say, when a security auditor found this in a few weeks or a few months down the road, and then expected the developer to track down this error and fix it. Okay, so you can imagine how difficult it would be for them to even understand what file this is, what is the exact file number, line number, and what the vulnerability is about. Okay. Now, the other important thing, like I was saying, is even if developers wanted to fix it, most of the times we've seen that they don't have the knowledge or the security expertise in order to fix it. So the contextual information here is very, very helpful. Okay. Now, let's go back here. We have two alerts here, okay, two errors. Again, this log injection, if you go ahead and clicked on where this error was, what file it came on, what path number it was on, it will give you the same contextual information. Okay. Another important thing is now suppose a developer had to go into files changed, right? And if they had to look down, you can see that even here within those files changed, which is again a very familiar flow for reviewers or developers, what they had to do is even if they came here, you can see that this alert is coming up over here, right? So at this point, I can either write a comment or I can tag someone for them to look at this, which is again very, very important. Okay. Now, I want to show you one more thing. If we went back to the pull request and looked at this one again, as a developer, I can go ahead and fix this now. And what you'll see is these checks will get kicked off again, and you can start using it right there. Okay. Now, one thing that you should note is, let me go back here to security tab and code scanning. Like I was mentioning, you can add a scanning tool really quickly. But the important thing is if you using say a third party static analysis tool that can produce results as the SARIF format, which is the static analysis results interchange format, you can actually upload the results into GitHub. The 61 workflows, or the ones that we shown here, are basically just the ones that we have seen most popular within the developer community, or the most frequently used ones. But if you have something that you're using, a tool that you're using, you can absolutely integrate with code scanning as well. Okay. Now let's go ahead and go into the security tab and look at the third thing that we have here, which is called secret scanning. Now, what secret scanning does is, we've spoken about this. Once you enable secret scanning, what's going to happen is GitHub is going to go over and look at all the either the partner provided patterns, okay, or the GitHub Advanced Security will look at all the secrets that were committed on day one and find all of those through all your repos and through all of the Git history that matches one of your patterns. Now, this is a very, very important aspect here. Okay, so for instance, you'll see all of these pattern providing partners that we have. I believe there are more than 60 now. We have all of these alerts for these patterns that were detected. For instance, you can see this NPM access token, which was within this. You'll see when, who made the commit, in which file, when was this made, so that no secrets are accidentally leaked. There is no compromise. Um, but if you had something which was specific to your project, to your repo, and you had a pattern which is not showing up here, or which is not, which is outside one of those partners that we have, you can also go ahead to the settings tab and you can scroll down here to the code security and analysis um, feature here on the left. And now within GitHub Advanced Security, you can see there's something called custom pattern. So what I have done here is I have added a pattern for a Visa credit card, but you can easily create your own pattern as well. So you can give it a name, you can give it a secret format, and this can be specified as a regular expression. The best thing is you can have some test strings here and you can run a dry run. So you want to basically ensure that if there is a error, say within your regular expression, then you don't have thousands of alerts generated incorrectly. So once you have a dry run, GitHub can send you an email or a notification saying this was completed. These are all the places where your pattern was found. So you can be sure that the pattern that you're defining is correct. Now let's go back and look at this Visa credit card pattern. So basically what you'll see here is the Visa credit card numbers begin with a 4. We have 12 digits, right, followed by these three optional numbers. Now, another thing you can do is you can also define the context in which this secret you think will occur. So you can specify what will occur before the secret, after the secret, and also basically give a context in which you expect these pattern to be found. Okay, so that's another thing about secret scanning. Now let's look at something more interesting as well. Like I was saying, one thing, of course, that we aim to do is make sure that any of these vulnerabilities, these errors that are showing up, these secrets and tokens, we are alerting you about that. But what if, like with dependency review, we can ensure that these don't even reach your code base in the first place? So in order to do that, what I've done is I have actually created a branch for this code repository. It was called Validate Secrets. And I've made some code changes and I'm trying to push this back into the main branch. Now, of course, if you go here, you know this, you can use, check out this repository locally onto your workstation. But what I chose to do is use code spaces. For those of you who are not aware of it, code spaces, think of it as essentially Visual Studio Code running in your browser. So you can customize your code space so it has all the extensions, settings, etc. And you can then distribute it across your team so your entire team has a consistent development environment, right? And the most important part is it lets you get started as a developer and be up and running from scratch in less than 2 minutes. So I had a code space already defined here called Psychic Space Pancake, which I had opened up here. Let's see if it's active. Okay, just in time. So like I was saying, I had created a branch where I had made a copy of the code that I had, right? And I'm trying to push this config.properties back into my main branch. Now I have a ADO credential that I have defined here. And what I want to do is let's go ahead and look at bash. And if I try to say push this file change back into my main branch, let's see what happens. Okay. And this is fabulous. We have secrets detected, this push failed. Okay. So let me increase the size here so you guys can see this clearly. Now, what you will see is GitHub push protection is in use. Okay, so what it's telling you is we found this Azure DevOps personal access token or a PAT. This is the location that we found it in, and this is the commit that occurred. Right now, again, you can imagine how important it is to have or block these pushes and before they even touch your code base, right? Now, but we are also very cognizant of the fact that this may not be, in an idealistic scenario. So, say you wanted this to continue on, GitHub does not want to disrupt your flow. So what we can do is actually, we've given you this option. If you want to remove the secret from the commit, this is the URL that we've been given. So if I paste it here now, you'll see that it will actually allow you to push this instance of that secret or of that token onto the main branch with the reason, and you can allow this. But what GitHub will do is within secret scanning, it will create a nice audit trail so that this is not lost. So, at some point in the future, you want to make sure that this is still being tracked and this is still, it still shows up. Okay. So now everything I spoke about is basically shifting left approach and empowering developers to fix their vulnerabilities. So what we wanted to show, and what we wanted to basically make sure, we leave with you folks today is that this tool is consider this is not just another tool. Okay, GitHub is an integrated platform. And what we are trying to do is make the developers' life as easy as possible and keep them as productive and make them as happy as possible, that they can actually leverage all of these security findings right within, where they are coding, right next to the place where they're coding, right within the pull request, which is a very, very familiar developer experience for them. And that is extremely important. Okay. Now we were looking at all of this from in terms of a developer persona. One thing I did want to tell you was as an admin, for instance, okay, or say a project lead who was looking at this tool, at this platform, you want to make sure that the return on investment is really easy and really quick, right? So I wanted to show you how easy it is to get started with GitHub Advanced Security, right? So now if I went over to the Octodemo organization, which is the organization that I'm a part of, and I went over to the settings tab over here. Now again, I'm scrolling here to the code security and analysis here on the left-hand side, if you can see it. And what I would need to do is just click enable all next to all of these features that you can see. As you can see, some of the features are automatically a part of GitHub Enterprise, but some of them are part of GitHub Advanced Security. The secret scanning that you can see here and the code scanning will actually be will show up under the repo settings. Now, what I can do is once I enable these settings, if I'm doing this for the very first time, it will take maybe a few minutes for these to start coming up within the security tab of your organization. But you can very, very quickly and easily enable this. So all you have to do is say enable all, go ahead, take a break, uh, grab a cup of coffee or tea, and then come back and see all of these results that then are populated within your vulnerability alerts right here. Okay, so one more thing I wanted to touch upon is definitely security overview, and this will be deprecated. Like I mentioned, we have the risk overview, the risk dashboard, and the coverage dashboard over here, which are also very important. And these are some of the things that we just announced at our GitHub Universe, which concluded just very recently. It was last week. Okay, so now to summarize, what I wanted to make sure is you understood that with Dependabot, you're getting source composition analysis. So we are looking at all of this open source dependencies that you can, save your developers time and have something like a bot running in the background in order to manage those. Um, Another thing we do provide is a static application security testing with code scanning, but we are also providing token scanning and push protection. And like you saw, we are even preventing unwarranted tokens from even entering your code in the first place by something like GitHub push protection, right? So we are truly bringing down the security debt, which is so important. Another thing we are, of course, providing is to clients and the ability and the flexibility to bring their own licenses, like I showed you with code scanning, and you can integrate with any of those tools that you're using, very, very seamlessly. So, just to conclude, the point is that the remediation rates that are possible with a platform like GitHub, and with features, through GitHub Advanced Security, it's extremely powerful and important that we increase the remediation rate and reduce the security technical debt. And that is why having this within as part of the developer workflow is so important. Okay, so that was all I had in terms of my security demo. Happy to take more questions offline. Thank you. And welcome. Cool. So I hope that was useful. Let me just, I know we are at time. Thank you so much, everyone, for all of your questions. I think you've been fabulous and interactive, and that's really, really heartwarming to us. Please keep the questions coming. We'll make sure that we try to answer them before we close the meeting off. I did want to definitely let you know that the GitHub Universe, our annual event, just concluded. We had very, very exciting announcements around security. I showed you the risk dashboard, the coverage dashboard. We also had something called as, it's called private vulnerability reporting. So in case someone found a vulnerability in your public repo, you would want to be the first to know, right? So maintainers of open source repositories can now receive private vulnerability reports from the community and collaborate on a solution. All of you are eligible for GitHub Enterprise, and most of these GitHub Enterprise features come under GitHub Enterprise. There's additional billing, like I mentioned, for GitHub Advanced Security for code scanning, secret scanning. If you are interested in that, would want to know more, please email us. So that's it for today, guys. Thank you. Thank you so much for joining. Really appreciate it.